In this video, we're going to be looking at the GDP multiplier. So the GDP multiplier tells us how changes in autonomous spending, changes in investment, disposable income, government spending are going to impact the total real GDP. So we're going to have an equation. We can rearrange this equation depending on which item we're trying to calculate. But basically, the idea is that we're going to get some sort of multiplier, some sort of number that represents the relationship between the total change in real GDP and some initial change in real GDP. The more real GDP changes compared to this initial change, the higher that number, that multiplier will be. So if you get a multiplier of 2, it means real GDP changed twice as much as some increase in aggregate demand. Or a real GDP of 5 means it changed 5 times. So aggregate demand is made up of consumption, investment, government spending, and net exports. Anytime we have an increase or decrease in one of those components, it's going to shift our aggregate demand curve. The shift in aggregate demand is going to have an increase or decrease in the real GDP. We're going to end up with some new equilibrium point in our economy at a higher level of real GDP. And this is going to be a different number than just the change in aggregate demand. So the multiplier effect tells us that any changes in spending lead to an even greater change in the real GDP. This goes for both increases or decreases. Governments have to be aware of this when they're making policy changes, especially if they're trying to impact the economy directly. So during times of recession, they need to spend less than what they want to have happen in the economy. If there's inflation and they're trying to reduce economic activity, they have to make cuts smaller than what they want to see happen in the economy because the effect multiplies. It grows. And partly this is because money is spent multiple times in the economy. So if you give me an extra $10, it doesn't only increase GDP by $10. I'm going to go buy coffee, and the person who works at the coffee store is going to earn some money from that coffee, and then they're going to go buy something, and then someone else is going to earn money. And so because we see spending happening, multiplying through the economy, we're going to see a larger change in real GDP. And now, one thing we want to remember too is that GDP represents production for an entire year. So we may have an initial change in aggregate demand. This is going to be some sort of like one-time change or some finite time period. The government sends stimulus payments. They're going to send everybody one check, right, or 2 checks, some amount of money. Real GDP, though, represents an entire year. So the GDP multiplier is helping us figure out when we have some sort of one-time increase or decrease in aggregate demand, how does that affect the whole level of production for the entire year? And so we're going to use this formula to figure that out. So if we know the ending or the change in real GDP, we know the initial change in aggregate demand, we can calculate the multiplier. Or if we know the multiplier and the initial change in aggregate demand, we can calculate the change in real GDP. So we can see that here on this graph. So we've got panel A and panel B. Both of these are showing changes in aggregate demand. Panel A is looking at an increase in aggregate demand. So we may have some sort of initial increase in net exports. That's going to be represented here by this dashed line in the middle. But through the multiplier process, because that money is going to be continually spent and create new production, it actually leads to an even greater increase in total real GDP. Panel B shows a decrease. So we have some smaller decrease in aggregate demand, which leads to an even bigger real change. Now let's go through some examples and practice actually calculating this. So to stimulate the economy, let's say the government reduces household taxes. This action increases disposable income by $80 billion. So we're going to look at some different numbers, and we're going to say if after 1 year real GDP increased by a certain amount, then our GDP multiplier is blank. So if you'd like, you can pause. You can go through and do these yourself, or you can watch along and do them with me in real time. Okay, so if after 1 year, real GDP increases by $240 billion, then our GDP multiplier is what? Okay, so we want to go back and use that formula. So our multiplier is equal to our change. That triangle, it's a delta, it means change. Change in real GDP divided by our initial change. Okay, so in this case, real GDP increased by 240 divided by our initial change of 80 billion. This is going to give us a multiplier of 3. Or we could do 400 billion. So if after 1 year it increased by 400 billion, we would do 400 divided by 80. And that's going to give us a real GDP of 5. And then last, 120 billion. So just do 120 divided by 80, and then we would get a multiplier of 1.5. We could also calculate the change in real GDP if we know that initial change and the multiplier number. So we're going to say if the GDP multiplier is blank and autonomous spending increases by 50 billion, then the change in real GDP is what? So we're going to have our multiplier, our initial change, and we're going to be figuring out that real GDP number. Again, you can pause here and work on this on your own, or you can do it with me. Okay, so if our GDP multiplier is 2, we have some autonomous spending increase by $50 billion, then our change in real GDP is what? Okay, so we would say 2 is equal to some number divided by 50 billion. Or, to make this a little bit easier, we can actually rearrange our equation to be that your multiplier times that initial change is equal to the change in real GDP. So 2 times 50 equals 100 billion. Okay, so if we have a multiplier of 2, an increase in $50 billion, then that is going to give us a change in real GDP of 100 billion. If our multiplier is 3.5, then that's going to give us a change in real GDP of 175 billion. And if our multiplier is 6, that's going to give us a change in real GDP of 300 billion. Alright, so that is the end of our discussion on calculating the GDP multiplier. Please let me know if you have any questions, and there will be more practice in your homework problems.